Hey everybody, so as promised, we are going to provide you basically a study guide for every problem on the practice test. The first section of the practice test, problems 1 through 5, says multiply and simplify. These are laws of exponents. I'd actually like to start by just on this board right here, I'd like to remind you of the 5 laws of exponents. We're going to be digging deep into these over a number of problems in the beginning here. The first is the 0 and the 1 rule. The second is the product rule. The third is the quotient rule. The fourth is the negative exponent rule. And the fifth is the power rule. And that's just to keep a list here of what we're looking at. Let's go over here. So we've definitely got some stuff mixed up. This is going to be, like I said, different directions. Sometimes the test will have different directions like this. We've got 6 times 6. We talked about this in class. This is not a 6. It's 6 to the negative 4th. This is not a 6. It's 6 to the negative 2. 6 would be 6 or 6 to the 1. So we cannot multiply those and call it 36. We're going to say that this is 6 to the negative 4 plus negative 2. This is an example of the which rule. Right now, we're talking about the product rule. In the product rule, we have numbers with the same base being multiplied, and we can add their exponents. Their base in this instance is not a variable, it's a number, it is 6. So we have 6 to the negative 4 plus negative 2 makes 6 to the negative 6, sorry. And then we are now going to have to address the negative exponent rule. And the negative exponent rule says that we're going to say that is 1 over 6 to the 6th. Okay, is that right? Good stuff, okay. Our next one, same kind of a concept here. We have the same base. Again, this is the product rule. The product rule alone should take care of the negative exponent. The base is 4. Again, that is not 4. 4 would be 4 or 4 to the 1. That's 4 to the negative 2 and 4 to the 5th. So we can't multiply 4 times 4 and call it 16. This is going to be 4 to the negative 2 plus 5, which is 4 to the 3rd. Sometimes on the exam, when the powers are to the 2 or 3 power, they will multiply them out. And that is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And so we could call this 1/64th as well. They may do one or the other on the test. It just depends. This is also the product rule. Now the common base is y, and we have a silent 1 up here. So we can call this y to the 3 plus 2 plus 1, which is y to the 6th. Okay, our fourth problem up here. This is interesting. This is actually can be construed 2 ways. We have parentheses being raised to greater powers. And so this is going to be both the product and the power rule. I'll tell you how it's the product rule. Right now, we have the same base of 3x, and 3x is being raised to the 2nd power, and it's being raised to the 4th power. So you could actually take that 3x and call that 3x to the 2 plus 4, which would be 3x to the 6th. And then at this point, we would infuse the power rule, where everything in the parentheses receives the power. And this would be 3 to the 6th and x to the 6th, okay? And they would not multiply that 3 to the 6 out. That's, like I said, it would just be to the 2nd and 3rd power, which would be the final answer here. Another way to do this problem is immediately to address the power rule and say, all right, that is going to be 3 to the 2nd, x to the 2nd, times 3 to the 4th, x to the 4th, where we bring all that in there. And now we kind of get into a little bit of what we did today with monomials times monomials, but because all these are being multiplied, we can rearrange this 3 to the 2nd times 3 to the 4th, and x to the 2nd times x to the 4th, where we bring our numbers together, our x's together, and this would be 3 to the 2 plus 4 and x to the 2 plus 4, which would be 3 to the 6th and x to the 6th. Same answer, a little different way of arriving there. This is a little more efficient to understand that base and that base are the same, and they're both being raised to those powers 2 and 4, so you can add those together. Product rule, they're being multiplied, and we can take it that way. Right here on number 5, we definitely have product again, and we will have to deal with the negative exponent rule as well. This is y to the silent 1, and y to the 1 plus negative 5 equals y to the negative 4, which then the negative exponent rule would be applied right here, and we'd say that's y, 1 over y to the 4. Squid, did we do all those correct? Okay, that's good. I have Squid checking to make sure we're not making any mistakes. We're going to pause for just a second. Okay, so the second part of the practice test, the directive is to evaluate. And we have 2 problems here. The first one is 10 to the negative 3rd. Now, to evaluate means that they're going to want us to take this numerically as far as we can go. So we're not going to just leave it as 10 to the 3rd or 1 over 10 to the 3rd. So first off, we need to recognize this is indeed the negative exponent rule. Okay. And we are going to convert that to 1 over 10 to the 3rd. To evaluate that, we would have 1 over 10 times 10 times 10, which is going to be 1 over 1,000. So 1 over 1,000. You want to check that, Squid, make sure we're solid on that. I don't know in the answer key if they went 1 over 10 to the 3rd, if they called it 1 over 1,000.
Either way.
Yeah, so they did have either or because both these are true. When I see the directive to evaluate, I'm thinking we're taking it all the way. 5x to the 3rd to the 0. We did this on our quiz today. This should look familiar. This immediately equals 1. If everything in the parentheses receives the power, everything's being taken to the 0 power, anything to the 0 power equals 1. So when we have evaluate up here, we know we're going to get numerical answers versus having, like in some of these problems over here, we have, a y value, a variable value. This is what differentiates these two. This is indeed the 0 rule of the 5 laws, and it is the power rule. If we want to apply that, we ultimately have 5 to the 1 times 0 and x to the 3 times 0, which makes 5 to the 0 and x to the 0. 5 to the 0 is 1, x to the 0 is 1, 1 times 1 is 1. That's the long explanation, but ultimately, if you understand the concept, everything in the parentheses receiving that 0 power would make that just a value of 1. We'll pause. Okay, so the next directive in 8 through 12 is to divide and simplify, which gives us a hint that this is going to be using the quotient rule. All 5 of these are ultimately related to the quotient rule. So I'm going to write that right here. Some of them will mix in the negative exponent rule. Again, this is not 4 over 4. If we had 4 over 4, we would just have, 4 over 4, or 4 to the 1 over 4 to the 1. That would equal 1. It's 4 to the 3rd over 4 to the 2nd. Ultimately, if we were to multiply those out, 4 times 4 times 4 would be 64 over 16. So what we have here, and if you took 64 and you divided it by 16, it equals 4. And you could do that on a calculator. But that's not how we're going to do this problem. We're going to do this problem using the quotient rule, which is 4 to the 3 minus 2. If I have the same base being, divided, as these are being divided in a fraction, we take the exponents and subtract them. 4 to the 3 minus 2 is 4 to the 1, and that indeed equals 4, which proves the mathematical side of it correct. On this next one, we have y to the 3 minus negative 8 makes y to the 3 plus 8, which makes y to the 11. Okay, our next one. The greatest thing about this right here is it just equals 1. If we can see that and we can cut ourselves some slack and quickly get to an answer, it's always nice to do. Anything divided by itself is 1. we could say this is the power rule, and we could say this is, 7 to the second over x to the second over 7 to the second and x to the second, and we could, work all this out. We could multiply those and say that's, 49x to the second over 49x to the second, but all we're doing is postponing the inevitable that this is 1 and this is 1 and that all equals 1, which we could see from the very beginning there. That's really easy to do. Another thing, though, if you were to take this in the true sense of the quotient rule, we could say, so we can just immediately say anything divided by itself equals 1. But this leads back to our proof of the zero rule this year. 7x to the second over 7x to the second. We have the same base, and ultimately we're saying we have 7x to the 2 minus 2. What is 7x to the 2 minus 2? Well, 7x to the 2 minus 2 is 7x to the 0, and anything to the 0 equals 1. Really kind of cool. We can prove that way as well. All right, but the truth is, this is the most rapid explanation here of this. So in this instance, we are proving it using basically the zero rule right here, okay, by using the quotient rule. Number 11, this is x to the negative 2 minus negative 5, which makes x to the negative 2 plus 5, which makes x to the third. Okay, and then finally here we have a to the negative 5 minus negative 3, which makes a to the negative 5 plus 3, which makes a to the negative 2. At this point, we have to apply the negative exponent rule because we can't have negative exponents unless we're talking about scientific notation. And this equals 1 over a to the second. And that is all. You can pause. Guys, so our next section, which is 13 through 23, I believe, just says simplify. And one of the things I want to do, if you just want to come over to this board here, is in numbers 1 through 25 on the practice test, we're literally just covering 4.1 laws of exponents, okay, and 4.2 scientific, notation. And so we come back over here at 13, 14, 15, basically 13 through 18. We're seeing a lot of power rule in 13 through 18, power rule. In numbers 13 through 18, we'll obviously have to probably address some negative exponents, things like that. And a lot of this we discussed in class today. So the first one I want to do here is this. We have negative 4, which is to the 1 power, which we're taking then to the second power. And you close enough? Okay, good. And we have y to the third power times the second power. And then we talked about this in class. Negative 4 to the second power and y to the sixth. Well, that negative, if we multiplied it, a negative 4 and a negative 4 would make a positive 16. So there's a chance that they'll have 16y to the sixth, but there's also a chance that the answer will be 4 squared y to the sixth. And we talked about this in class, that when we have an even exponent, the negative goes goodbye, okay? To the second power, to the fourth power, to the sixth power, that negative will go goodbye because this is a simplified problem. So it could be either one of these two answers. Here we have, again, everything in the parentheses receiving the power. This is the power rule. 2 to the 1 times 4, a to the 1 times 4, silent ones on both those, and b to the 2 times 4. This makes 2 to the 4th, a to the 4th, and b to the 8th. 2 to the 4th is 2 times 2 is 4 times 2 is 8 times 2 is 16, a to the 4th, b to the 8th. It could be either or in a test situation, okay? You able to check these answers, or you're okay if you can't? We got Squid running double duty, cameraman and checking to make sure we're not screwing up the minds of the youth of, BYU Idaho or anywhere else. Here we go. So everything in the parentheses receives the power, still the power rule. This is going to be 2 to the 1 times 3, q to the 2 times 3, r to the 3 times 3, all over s to the 5 times 3. I feel like our practice test is giving you, there's 25 problems on a test. We're giving you 50, 54 problems on this practice test, and we're giving you just gobs of the laws of exponents here to really make sure you're solid in this. My s's look like 5s. I'm trying to make sure this is really clear to you. This is 2 to the 3rd, q to the 6th, r to the 9th, all over s to the 15th. 2 to the 3rd also could be communicated as 8, so this could be an or. 8, q to the 6th, r to the 9th, all over s to the 15th. Either one of those would be an acceptable answer. Okay, so we talked about multiplication of polynomials today. This is kind of a mix of the power rule in 16, 17, 18, and mono times mono. Okay, so the first thing I want you to recognize here is that we can't multiply this mono times that mono until we take care of the exponents. It's kind of the order of operations. I can't multiply until I take care of exponents. Exponents comes first. Power rule says everything in the parentheses receives the power. Again, parentheses have to be addressed first too in the laws of exponents. In the order of operations. So this is going to be ultimately, again, I'm telling you, this is the power rule, but it's also going to be a little bit of multiplication of polynomials. So this is 2 to the 1 times 2, x to the 2 times 2, which is 2 squared and x to the 4th, which I'm going to go ahead and call 4x to the 4th. And we're going to leave that parentheses around there because we just took care of this right here. On this one here, I'm going to have negative 2 to the 4th, x to the 3 times 4. And I'm going to show you something interesting here. So we know that, in essence, negative 2 to the 4th is the same as 2 to the 4th. And this is going to be x to the 12th, okay? And if I put this in a parentheses, just like this is in a parentheses, I can see that I'm going to be multiplying these two. So by multiplying 2 times 2 and getting 4, I create an issue because I'm not going to have 2 to the 4th and multiply that out. So this one, we could get ahead of ourselves here. I think it's ideal in this instance, if you have a problem like this on the test, and you very well could, to leave this in exponential form. And we got to understand, because that was an even exponent, 4, the negative goes kaput. So this is going to be this mono times this mono. We can rearrange this to 2 to the 2nd, 2 to the 4th, x to the 4th, x to the 12th. And now we have some product rule going on here, right? Because we have the same base, we can add the exponents. This is 2 to the 2 plus 4 is 2 to the 6th, and x to the 4 plus 12 is x to the 16th. And that is my final answer for that problem. Yeah?
Yeah, it goes to 64 in here, but the 2 to the 6th.
So ultimately, it looks like you could do 2 to the 6th, x to the 16th. In the same respect we were talking about, what if we had taken this and called it 4 x to the 4th in this one here, and we took it to 2 times 2 times 2 times 2, which would be 16 x to the 12th. Then we would have, in this instance, instead of 2 squared, we'd have 4. Instead of 2 to the 4th, we'd have times 16. And that's where they could come up with this being 64 x to the 16th, either way. I would imagine in a test situation, you're probably more likely to see this. You could see this as well. All right, so this starts getting a little bit hairier, a little more complex. But in the end of the day, again, we have to address parentheses first, the power rule, okay? We have 4, and when we say that, we talk about in the laws of exponents, there's no order of operations with how we apply the laws of exponents. But you have a problem like this where you're multiplying a whole bunch of entities, we have to obey the order of operations in the sense that we're going to apply this 2 into this parentheses, x to the 5 times 2, okay, is going to be 4 times x to the 5 times 2, which is 4x to the 10th. And then over here, we're going to plug this in, and we're going to have negative 2 to the 1 times 3, x to the 4 times 3, which is going to make negative 2 to the 3rd and x to the 12th. Negative 2 to the third is, in essence, negative 2 times negative 2 times negative 2, which is negative 8. So this is going to be 4x to the 10th times a negative 8 x to the 12th. Why did I put the parentheses there? So it doesn't look like we're subtracting these, okay? All right, so now mono times mono, what we learned today. So what's interesting, in 16, 17, and 18, we're kind of combining the laws of exponents power rule with the multiplication of polynomials, multiplication of polys, with the mono times the mono. So we're taking two concepts, and so in essence, on these ones, we're really looking at section 4.2 and 4.5, kind of combining here. So we come back to this, and we're going to have numbers with numbers, 4 times negative 8, and x's with x's, x to the 10th and x to the 12th. This makes negative 32 x to the 22nd. We're going to add the 10 plus the 12. We good on this one?
Yep.
All right. Last one. Again, mono times mono. Remember what we said before. I just want to bring this up. If we have 3x to the third and we had 3x to the third, right? If they have the same base, we could just say that's 3x to the 3 plus 3, which would be 3x to the 6. But these don't have the same base being raised to the third. They're completely different monomials. And so we have to take this problem and we have to say, all right, this is going to be 3 to the third, x to the third. And then we're going to have negative 2 to the third, x to the 6th. Notice that I have skipped a little bit here. I have kind of assuming at this point that you understand that's 3 to the 1 times 3, x to the 1 times 3, negative 2 to the 1 times 3, and x to the 2 times 3. And that's how we got 3 to the third, x to the third, negative 2 to the third, and x to the 6th. In this instance, I have different numerical bases. 3 to the third, 3 times 3 is 9 times 3 is 27 x to the third. This is going to be 8, negative 8 x to the 6th, because negative 2 to the third is negative 2 times negative 2 times negative 2 is negative 8. So I'll end up with 27 times negative 8 x to the third, x to the 6th when I combine these, okay? Did they go ahead and multiply that big number out on that one?
Yeah.
Yep. And so 8 times 27 is going to be 216. Yep. So I got negative 216 x to the 3 plus 6. X to the 3 plus 6 makes x to the 9th. That is the final answer for that one. Okay? All right. So that takes us through 18. But no new directions here. In 19 through 23, we're seeing some, I would say, scientific notation, but maybe even more than scientific notation. There's some scientific notation. There's also a couple of questions here. And I've seen this kind of stuff happen on tests before. X to the negative 8 says express using a positive exponent, okay? So these two right here, 19 and 20, are exemplifying the negative exponent rule. And we're just randomly applying this here. We're saying, yep, that's going to equal 1 over x to the 8. Put it in its opposite place in the fraction, make it positive. It says express this using a negative exponent. Okay, that's kind of weird. We don't usually do that, but it's working backwards. And we're going to say, well, that's y to the negative something. If you put it in its opposite place, the fraction, it would become negative. It was already positive, right? Number 21, convert to scientific notation. We know we need to move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. 1.3 times 10 to the positive 9, because the original number was more than 1, and we moved the decimal to the left. Next one, convert to decimal notation. So we have 3 times 10 to the negative 6. Think about this for a minute. I have 3.0 ultimately times 10 to the negative 6. If I am going to take this in the negative direction, I'm going to move it left 1, 2, 3, 4, 5, 6. Now my decimal is there. I can say 0.0000003. that goes. So I have 0.000003. And I've converted that to its decimal notation. How did I know to move to the left? Well, a negative exponent means I need the original number to be less than 1. If I moved it to the right, I'd have, 3 million most likely, and that would be bigger than 1, so that would be in the positive direction. So that's how I knew I wanted this to go in the negative direction. I fill in the loop-de-loos with zeros. It's just a way to keep track of it. Last one, convert to scientific notation, 58,405. So the decimal is right here, right now, and we're going to move it 1, 2, 3, 4 places and call this 5.8405 times 10 to the, I moved it 4 places. The original number was more than 1, so that's positive. And sometimes we get a little uncomfortable with this because we're like, okay, well, should I have just moved it 1 place? Remember, in all of these problems, scientific notation, the definition of scientific notation is only one digit to the left of the decimal. That digit cannot be 0. If we had stopped anywhere previously, we'd have multiple digits to the left of the decimal. It can only have 1. Good with all these? Okay, let's pause. Okay, so our next 2 problems are definitely from the scientific notation realm. These are the ones where we have some problems in scientific notation, either being divided, in this instance, top to bottom divided, or being multiplied, side to side being multiplied. And we talked about the concept here where we take numbers with numbers and, base 10 with base 10, which means that we can kind of cut this problem like this. Let me come over on this side. And we can drop that times into here. And so we take these 2 numbers and divide them. 3.6 divided by 5.0. What do we get?
0.72.
Okay, so we get 0.72. I already see a problem with this. This is not going to be in scientific notation because there's only 1 digit to the left of the decimal, and that digit is not 0. So I'm going to have to convert the answer to scientific notation after I do my math here. This is 10 to the 5 minus negative 4, right? These are being divided. I can apply the quotient rule. Minus and minus makes plus. This ends up being 10 to the 9th, okay? So again, same base. The base is 10. And because of that, I can say this is 5 minus negative 4 because of that quotient rule, which is 10 to the 5 plus 4, which ends up being 10 to the 9th. We put that down here. So now I need to drop that times down here. And I need to just, right now, again, cut this right like that. And 0.72, I'm going to move this 1 place. That becomes 7.2 times 10 to the negative 1. That's a negative 1 right there. Why? Because the original number was less than 1. I moved it 1 place. That's the 1 value. But because it was less than 1, that's the negative value, which is already times 10 to the 9th. These 2 now can combine using the product rule because they're being multiplied to have the same base. This becomes 10 to the negative 1 plus 9, which is 10 to the 8th. This ends up being 7.2 times 10 to the 8th. Okay. Our next one here, again, same kind of a concept. Over here, we were dividing, so we divided the numbers. Over here, we're multiplying, so we're going to take numbers with numbers, 3.2 times 1.9, and then we'll have times 10 to the 7th, times 10 to the 3rd. 3.2 times 1.9, we put it in a calculator. What do we get?
6.08.
6.08. Squid's like the holy math ghost. And we have 10 to the 7 plus 3. We have 6.08. Are we going to be okay with that in the final answer? We are, because there's only 1 digit to the left of the decimal, and it is not 0. And so this is times 10 to the 10th. And that is the final answer. Okay? We good, Squid? Okay, cool. Let's pause. Okay, guys, so our next segment that we're going to be covering is numbers 26 through 33. Before we do that, we're going to continue to add to this and come back to this and refer to this. So at this point, we've completed numbers 1 through 25, which covers 4.1 and 4.2. Numbers 1 through 20 on the practice test is all laws of exponents from 4.1, all 5 laws being exemplified in there. 0 and 1 rule, product and quotient rule, negative exponent rule, power rule. Numbers 21 through 25 were just scientific notation from section 4.2. And now we're going to, cross the barrier into the polynomial world. And we have covered all of these sections and we've already identified, but in numbers 26 through 33, we talked about the basics of polynomials in section 4.3, and then we reviewed it with more complex polynomials in 4.7. We're going to do that right now. We're going to hit these problems. Let's look at 26. Evaluate the polynomial x to the fourth minus 2x to the third plus 6 when x equals negative 3. We do have to understand that that negative 3 will have a parentheses around it to the fourth, and minus 2 times negative 3 to the third, and plus 6. Why does it have a parentheses around it? Because x is what is being raised to the fourth power, and we're saying x equals negative 3, therefore negative 3 is being raised to the fourth power, not just 3. The negative is part of it. Negative 3 to the fourth is negative 3 times negative 3 times negative 3 times negative 3. And we can do that on our calculator. We do not need to do this without, but that is positive 81. And then we'll have minus 2. And again, we're following in this kind of a scenario with all numbers, one of our old tools, the order of operations. We're going to have negative 3 to the third. We already know that negative 3 times negative 3 times negative 3 is positive 27. So we have negative 2 times 27 and then plus 6.
Negative 27.
I'm sorry, negative 27. Thank you, Squid. This is 81. Now a negative and a negative make a positive 54 plus 6. I do my math a little less than if I'm not using a calculator. I like to take things that make really fast sense to me. I could do 81 plus 54 on a calculator and get 135 and then add 6 to that. 135 plus 6 makes 141. But another way to do that is just say 54 and 6 is 60, and 60 plus 81 is 141. That's just the way I would have done it in my head, okay? So 141, okay? Evaluating a polynomial. Simple substitution, take the value, plug it in, use the order of operations. The order of ops is the tool. That's a Karate Kid tool we learned in the R chapter. This is a big, wordy problem. It is simple substitution. It is evaluating a polynomial when given values. A smartphone company determines that when it sells S smartphones and C cases, we have S's and C's here, the total profit, P, earned by the company will be exemplified in this polynomial equation, P equals negative 0.4 squared S. Is that the squared by the 4 or the S?
It's by the 4.
Yeah. Plus 280S plus 30C minus 2,500. The question here on the right side is, what is the total profit earned when the company sells 70 smartphones and 30 cases? So P is the total profit that we're looking for, negative 0.4 squared times S, and the smartphones in this instance is 70, plus 280 times 70, plus 30 times, well, 30 cases, 30 times 30, minus 2,500. We're going to employ Squid with his calculator here. What is a negative 0.4 squared? Is that going to be positive 0.16?
Here I have negative 0.16.
What's that?
Negative 0.16?
Yep. That's right, because the negative is not being squared. Is that right? We got to think about that for a second. This problem is annoying, to say the least. It's not in a parentheses, so it should be negative 0.16 times 70 plus, let's go ahead and multiply 280 times 70. What do you get there?
19600.
Okay, 19,600 plus 30 times 30 should be 900.
Correct.
Minus 2,500. P equals negative 0.16 times 70. What do we get there?
Negative 11.2.
Plus 19,600 plus 900 minus 2,500. Now it's just calculator time. It's all addition, subtraction. We're going to plug in negative 11.2. We're going to add 19,600. We're going to add 900, and we're going to subtract 2,500.
17988.8.
And how does that measure up with the answer?
We did something wrong.
Well, I'll tell you what's wrong. It's going to be that negative there. I guarantee you. So, unless we did something right. Let's pause for just a second. Hey guys, so we ran into a typo in the practice test, and we were kind of wondering why this was squared here in the very beginning. It's kind of odd. Usually you would square the variable, the constant wouldn't be squared. It's more math speak, but basically we did all of our math right, we wrote the problem right, but we're going to redo this and apologize to make you look at this twice in the video. But what's nice is we're sending out a message to everybody, and at least we were able to discover this problem so you don't have to go through this pain on such a problem like this. The squared should be moved from here out to here, and then that 70 is what should be squared. And so this ends up being, and we're gonna redo this math here, and this will all work out and give the correct answer now, negative 0.4. Well, we square 70, and you're gonna get 4,900, is that right?
Yes.
Okay. And then when you multiply those two times each other, negative 0.4 times 4,900, what do you get?
Minus 1960.
Yeah, minus 1960. Yeah, that's not the year Brother Rich was born. I'm not that old yet. Okay. And so now we have negative 1960 plus 19,600 plus 900 minus 2,500. All the other math was correct. And that is going to give us the correct answer of
$16,040.
Yeah. And that is the profit for selling 70 smartphones in 30 cases. Thanks for your patience there. The beauty is that we found this problem. And so there's a message being sent out on Canvas. You will have this message before you ever watch this video, letting you know that that needs to be switched there. So we'll be good. Okay, let's go to number 28. Identify the coefficient of each term of the polynomial. How many terms are up here? Terms are separated by plus or minus signs, 3 terms. The coefficient of the first term is 3. The coefficient of the second term is negative 7/2. And the coefficient of the last term is negative 9. Okay? Identify the degree of each term and the degree of the polynomial. There are 5 terms here. Remember, coefficients are the big numbers. We're not worried about big numbers, we're worried about little numbers. And so the degree of the first term is 4. The degree of the second term is 0, right? Because there's no x there. And we talked about how that is, going to be like x to the 0 there. And then the degree of the next term is 2, and of the next term is 3, and the next term is 1. Okay? And the degree of the polynomial is the greatest degree of any one term. So these are the degrees, of the terms. So the degree of the actual entire poly is 4. We don't add them all up. 4 plus 2 is 6, plus 3 is 9, plus 1 is 10. We take the greatest degree. So the degree of the polynomial is 4. Classify this polynomial, x squared minus 5, as a monomial, binomial, trinomial, or none of these. Obviously, that's 2 terms. It is a binomial, and that's it for these problems. Okay, we're back, and we're still, if we look at this board, we're still in this zone of numbers 31, 32, 33 in the basics. We come over here, we're being asked to combine like terms. We know how to do this. Simple method, 4a squared, 8a squared. That's a single a, different terms. So 4 and 8 make 12a squared minus 6a. There's no more like terms. We're done with that problem. Every one of these, we have 4 terms separated by plus or minus signs. Every one of them is a y to the third. We literally have a 1 and a negative 1. So these two cancel each other out. It's kind of a goofy problem a little bit. Negative 7 and positive 3 make negative 4y to the third. So all those combined. And we go to this last problem here. We have, if we look at separated by plus or minus signs, we have 1, 2, 3, 4, 5, 6, 7 terms. They're asking us to combine like terms and then arrange the problem in descending order. We know descending means by degree, right? Not by the coefficient, not by the big number, but by the little number. And so we're going to take our like terms. We have 6. Do we have any other whole numbers? Yes, we do. We have 8. 6 and 8 make 14. We know that's going to go at the end in descending order, but we'll leave it there for now. We'll just do the descending order thing at the end. We have x squared. That's not an x squared. That's not. This is. That's not, I like to sometimes, as I've told you before, cross out the ones I've done so I don't look at them anymore. In my work, I have -7 and -2. That combines to make -9x squareds, okay? We're not doing an arithmetic lesson. We know -7, -2, same sign, same means you add them up. -7, -2 make -9. Okay, we can cross those out, get them out of our face, okay? We got -8x, that's not an x, it's an x to the third, but this is an x, positive 2x sign before the terms go with it. -8, positive 2 make -6x. These can be canceled out. And now we look at everything that's crossed out. This one's just dropping down into the answer, okay? Because there's no other x to the thirds. This is my greatest degree. It goes first. Descending means greatest to smallest. Okay, I like to cross that out, and then I don't look at it anymore. I have -9x squared, 3, 2. Okay, -6x, that's to the 1, and then plus 14, putting that in descending order. We're solid. Let's pause. We're ready to jump into our next section of the practice test, numbers 34 through 37. This comes directly from 4.4, again, reviewed in 4.7 with, we did, these same things with polynomials with more than one variable. But this is addition and subtraction of polynomials. Let's come over here and talk about addition and subtraction polynomials on this board. Remember, in section 4.4, we learned that the addition and subtraction of polys was simply 1, to distribute parentheses, and 2, to combine like terms. I'm not going to lie, okay, straight up, I'm going to be blunt with you guys. That's the way I always have been, the way I always will be. I think these problems are kind of a pain in the butt. Start throwing in fractions and decimals, and it's sometimes it feels like a lot of busy work. We're going to rip through these, you will see one or two of these on the test. It's a legit, fact. So let's briefly pause. Two of you, if you got all right, so our first one here, we have this parentheses plus a parentheses. In other words, a poly plus a poly, addition. Do I need the parentheses? I do not need the parentheses because there's no distributor except 1, no distributor except 1. When I subtract, I would need to distribute that through, but this is addition. So this is just in essence 5x to the third minus 5x squared plus 9x minus 10 minus 7x to the fourth plus 6x to the third plus 8x squared plus 10. Can I share something with you guys really quick and show you something interesting, maybe a little bit dynamic, a little bit different, but could help make this go a little bit faster for you? When you get rid of the parentheses and you're taking a test or you're doing a practice test, write this one here, get rid of that parentheses, and then look at this. Where does 7x to the fourth go? I'm going to put it right here, 7x to the fourth. There's no other fourth. I'm putting these underneath. Plus 6x to the third. Now those are lined up so I can add them up. Plus 8x squared. Okay, and there's no x term, but I do have a plus 10. Notice the beauty of this. Now these are all like terms. They're lined up with each other. So you can just say, hey, that's -7x to the fourth. The other thing it's going to do is going to put it in descending order for you, which is probably the way the answer will be written in the answer key. Is it? Squid's saying yes. He's giving me the nod. 5 and 6 make 11x to the thirds. -5 and positive 8 makes plus 3x squared. Then 9x just drops down, and these two cancel each other out, and that's your answer. So that little verticality thing is kind of a cool trick. Can be a cool trick if anything's cool in math. All right, we have a polynomial plus a polynomial. Again, don't need the parentheses anymore because there's no distributor, okay? So this is going to be x to the fifth plus 2/7 x squared and minus 9. We get rid of this, then we can take those and say, hey, I got 2x to the fifth. I have plus 5x. Where does that go? Well, it's going to kind of get squoze in between here. And I have minus 1/7 x squareds, right? These, notice I rearranged those as I read them so that I can do my verticality thing here, where I have 2x to the fifth and 1x to the fifth. That makes 3x to the fifths. 2/7 minus 1/7. And hey, if you don't like this, just go back to your old way of saying, look, okay, I'm just showing you this really quick here. We can get rid of the parentheses, okay, because we don't need them. All right. And again, if you don't like this little vertical trick thing I'm doing here, then don't do it. You know, do we have any other x to the fifth? Look across here. Yeah, I got x to the fifth, and I got 2x to the fifth. That makes 3x to the fifth. I got 2/7 x squared. I got negative 1/7 x squared. 2/7 minus 1/7 makes plus 1/7 x squared. Or you can do it vertically here. I got negative 9. I don't have any other numbers. To put that in descending order, the negative 9 is going to go out here, and the plus 5x is going to go here because it's by itself as well. So that's the nice thing about the verticality. It does put it in descending order for you, okay? And then we have a subtraction. So we have 2 additions and 2 subtractions. Yeah, I guess we're getting a lot of practice here. I mean, this practice test is going to freaking make you super math muscly, okay? You're flexing, all right? You're on steroids, I hope. Okay, do we need the first parentheses? No, the distributor is just 1. So I have 9x to the third minus 8x squared plus 10x minus 16. Do I need this one? Well, fetch, yes I do. That's got to go to here, it's got to go to here, it's got to go to here, it's got to go to here because I'm subtracting polynomial minus a polynomial. I have negative 5x to the fourth from that up there. I have negative 9x to the third. That's kind of nice. Those are going to cancel. I have minus 7x squared. The thing you got to be careful of is you just got to make sure you're lining up like terms with like terms. And I have plus 15. There's no x term on that one. But guess what?
Flip those last 2
I
signs.
have not changed the signs of these. And this is the number one mistake that can happen in this kind of a problem here is you can forget to bring the negative to everything. So I like to take my finger and go negative 5x to the fourth, negative 5x to the fourth. Negative 9x to the third, negative 9x to the third. Negative and negative makes a positive 7x squared. Negative to a negative makes minus 15, so you don't make those mistakes. Negative 5x to the fourth. These cancel. Negative 8 and positive 7 make negative x squared because it's just negative 1. We don't write 1. We just write negative x squared. 10x drops down. These two combined, they are both negative, so you add them, right? Because they have same sign. It's negative 31. Okay, we solid? Okay, let's come here to our last one. This has a few decimals in it. Same kind of a concept here. I'm going to do this one different than the others. I'm not going to do the verticality thing. I'm just going to go old school here. X to the third minus 0.8x squared and minus 13. I'm showing you both ways so you can kind of do it the way you want. I actually like my old school way. I rarely write them vertical like that. I've seen people do that before. It can be effective. I just like, I like taking this through here, 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 and here. I find that I forget the negative when I go vertical. This is going to be minus 3x to the fourth. This is going to be plus 0.2x squared. This is going to be minus 0.5x. And this is going to be plus 13. I have a polynomial minus a polynomial. Don't need that parentheses. Have to distribute the negative through there. The subtraction of polynomials. I look across here. I don't have any other x to the thirds, okay? So I've got x to the third right here. I'm going to get rid of that right there. I have negative 0.8x squared. I have positive 0.2x squared. I don't have any other x squareds. Negative 0.8, positive 0.2 makes negative 0.6x squareds, okay? Cross those out. I don't want to look at them anymore. Okay, I have a negative 13. I have a positive 13. Those very serendipitously get rid of each other. I have a negative 3x to the fourth. I don't have any other x to the fourths. I have a negative 0.5x. I don't have any other sole x points. Is this written in descending order? It is not. This one term has got to swing up front. Negative 3x to the fourth plus x to the third minus 0.6x squared and minus 0.5x. We put that in descending order and we are done. Guys, so we have completed through number 37. We're going to dive in and do multiplication of polynomials and division of polynomials all across our boards here right now. Multiplication of polynomials is 38 through 44 on the practice test. These come from sections 4.5, 4.6, and again 4.7. As you know, we've described what 4.7 is. It is, again, just the compilation of basics, addition, subtraction, and multiplication with polynomials in more than one variable. And then we just have 2 problems, 45 and 46 in division of polynomials. There's a small representation of that on the test. And then we will, after we take a little break in between multiplication and division, we will go over the review questions. And there are 8 of them. to get you prepared for the retro questions on the test. Let's jump in here. The first problem we have here is a mono times any poly. If we remember, the monomial has to go to here, and to here. We're going to have negative 4x squared times 9x squared plus negative 4x squared times negative 4x plus negative 4x squared times 9. Okay, don't worry about that right now. Okay, numbers with numbers. Negative 4 times 9x squared, x squared. This is going to be plus, and we're going to say negative 4 times negative 4, and we have x squared and x. And we're going to have plus negative 4 times 9 and x squared. Negative 4 times 9 makes negative 36. X squared makes x to the 4th. Negative 4 and negative 4 make positive 16. X squared and x make x to the 3rd. Negative 4 and 9 make negative 36 x squared. Did we do it right, Squid? Okay, all right. We're going to erase some of that problem. Okay, so you want to take a look at that. You're good. We can get in here and do this. Okay, we have here a binomial squared, okay? If you look at these next few problems, we have a lot of this represented, and you'll see it on the test. You just see these kind of problems on the test. If you look at some of these problems in the practice test, they're just very representative of what you're going to see on the test. You definitely see a lot of this binomial square crap. And so we know we can't take a shortcut. We can't just apply the square to here and here. We talked about that. We have to take x times x minus 1/3 times x minus 1/3. Gotta hate the fractions, but we just gotta deal with it. Okay, just gotta put our heads down and make it happen. This x has to be multiplied times x minus 1/3, and this negative 1/3 or plus negative 1/3 has to be multiplied times x minus 1/3. That's just me doing that extra step where I take this times this and this times it. This times this parentheses, this times this parentheses. You could just do it. You could skip this step. X times x plus x times negative 1/3 plus negative 1/3 times x plus negative 1/3 times negative 1/3. We end up with x squared minus 1/3 x minus 1/3 x, and this makes plus, a negative times a negative makes plus 1, and a 3 times 3 makes 1/9. Now look at this. These are like terms. We say the middle terms often combine. It's an x and an x. We have a negative 1/3 and negative 1/3. And I hope that you can do this without a calculator, but it's okay if you use your calculator. But this is negative 2/3 x, right? The x squared comes down, the plus 1/9 comes down, and that is your final answer for x minus 1/3 squared, okay? Again, we're going to erase some of this. Kind of jamming these up on the board here, okay? All right, 4x plus 3 times 4x minus 3. We talked about this. And we learned that when we have the exact same terms, but one's being added, one's being subtracted, that we have conjugates, okay? And we know that the middle terms, they will actually cancel each other out. We're going to get 4x times 4x minus 3, right? 4x times this, 4x minus 3, plus 3 times 4x minus 3. This makes 4x times 4x plus 4x times negative 3. Plus 3 times 4x, plus 3 times negative 3. 1, 2, 3, 4, mono times monos. Number to number, 4 times 4, x and x. Here we'll have plus 4 times negative 3 and x, plus 3 times 4 and x, and plus 3 times negative 3. Just writing a little extra here to get my numbers with my numbers, my variables with my variables. I get 16x squared minus 12x plus 12x and minus 9. Indeed, these two cancel out, and we get 16x squared minus 9. I did talk to you that in this kind of a problem where they're conjugates, you can take the first terms, 4x and 4x, and multiply them. Think about that for just a second. What is 4x times 4x? Well, it is 16x squared. And then you can take the last two terms, 3 and negative 3, and you multiply them and you get negative 9. That's right there. And you could just do that knowing that the middle terms cancel out and call this 16x squared minus 9 and take that shortcut. But shortcuts are dangerous, and sometimes it's more healthy to just do this, cancel them out, and know that you did the problem correctly. I'm not going to erase this. I'm just going to jump in here. 6t plus 7 squared. The killer here is to understand this is not 36t squared. I write my t's as capitals because my lowercase look like plus signs. And then, I could say, plus 49, and this does not equal this because we can't just apply the square to these. We can't take a shortcut. We have to take 6t plus 7 times 6t plus 7. Okay, so, and the other problems, I did the 6t times this parentheses and the 7 times this parentheses. And this one, I'm going to cut that step out, and I'm going to just show you, what if I take 6t, right, times this first term, 6t, plus 6t times the next term, 6t times 7. Now, I'll take plus 7 times 6t and plus 7 times 7. If you like the intermediate step coming back to this, where I take, 4x and multiply it times that parentheses, and then the 3 multiply it times that parentheses, then do that. But if you want to go directly to this step like I did here, that's fine too. You definitely don't have to write 6 times 6 and t, and you don't have to write 6 and 7 and t. You could just do this in your head, and 7 times 6 and t, and plus 7 times 7. But I'm putting the numbers with the numbers and the variables with the variables to emphasize our, mono times mono principles. 36t squared plus 42t plus 42t plus 49. These combine. 36t squared plus 84t plus 49, and we are done. Okay. Holy crap, we're on a math fetching marathon here. Okay. It's kind of good for me to do a whole assignment like this, and I'm looking at it going, it's a lot of work. You guys got your hands full. Okay. X to the 7th minus 1 times x to the 9th plus 1. Okay. Binomial times a binomial. A lot of bi times bi action going on this test. X to the 7th times x to the 9th plus 1 plus negative 1 times x to the 9th plus 1. You see what I did? X to the 7th times this parentheses, that's right here. The negative 1 times this parentheses, that's right here. X to the 7th times x to the 9th plus x to the 7th times 1 plus negative 1 times x to the 9th and plus negative 1 times 1. This is going to make x to the 16th because the power rule says they have the same base. I can add those. This is plus x to the 7th. This is minus x to the 9th. This is minus 1. Notice the middle terms did not connect here because we have these different x to the 7th, x to the 9th. So the middle terms did not combine. So we put this in descending order, x to the 16th minus x to the 9th plus x to the 7th minus 1. Sometimes it works out that way. Okay. I'm going to erase this a little bit. Now we got this trinomial times trinomial. And we know these are just bears, right? Just fetching huge problems. 3 terms times 3 terms. Woo! Okay. I'm going to use a couple of different colored pens here. Going to take x squared and multiply it times that whole parentheses. So ultimately I have x squared, right? That first term times the next parentheses, 3x squared minus 8x plus 2. We good? Okay. And then I'm going to go ahead and leave the next one as black. So I'll have plus 3x times 3x squared minus 8x plus 2. And then I'm going to do my final one in red. Okay. And I'm just doing this to color code. You don't obviously have to do this, but it just helps you to see at home the differentiation between each of these terms being multiplied times this parentheses, this term times that parentheses, here, this term times that parentheses, here, this term times that parentheses, here. So I end up here with x squared times 3x squared plus x squared times negative 8x plus x squared times 2. That is simply that one right there. This is going to be plus 3x times 3x squared plus 3x times negative 8x plus 3x times 2. And that is just this right here. I'm really spreading this out. And then this one will come all the way over here, and this will be plus, right, 4 times 3x squared plus 4 times negative 8x plus 4 times 2. The one thing that you don't want to do is save a tree and not write on enough scratch paper when you do a problem of this magnitude. I've taken up the whole fetching board here, okay? I have 1, 2, 3, 4, 5, 6, 7, 8, 9 mono times monos. Why? Because I have 3 terms times 3 terms, and 3 times 3 makes 9. 9 mono times monomials. This is going to end up being, and on this instance, I'm not going to reorganize these. I'm going to tell you, I can do the rest in my head. 3x squared is x to the 4th. This is going to be negative 8x squared x makes x to the 3rd. Plus 2x squared. 3 times 3 is plus 9. If it helps you, if you look at that and you're like, I'm confused, then write 3 times 3 and x squared. Just write that intermediate step there. You don't have to do it for every problem, but some of them you may want to do that. So this ends up being plus 9x to the 3rd. Again, 3, negative 8, x and x. You like that? Makes you comfortable? Do it. Okay? And this here, 2 times 3 is plus 6x. Coming down here, okay, I'm going to end up with plus 12x squared. Over here, negative 32x. And down here, plus 8. Holy mackerel, we got a lot of shizzle on this drizzle. Okay? So we got 3x to the 4th gone. Okay? There's no other x to the 4ths. I looked. Okay? I have a negative 8x to the 3rd. I have a positive 9x to the 3rd. I don't have any other x to the 3rds. Those two combine to make 1x to the 3rd, which we just call plus x to the 3rd. I want to cross those out. I don't want them in my vision when I'm looking at the rest of this. I can use different colors sometimes. I got 2x squared here. I got negative 24x squared there. I got 12x squared. I got all my x squareds. I got a 2 and a 12. Make 14 on the positive side. A negative 24. I have negative 10x squared. Right, guys? Yes, I do. Right? Bong, bong, bong. I don't think we're going to talk about bongs this late in the hour. Positive 6x, negative 32x, and I got what? Negative 26x. Okay, you can use your calculator. Just take negative 32 and add 6, or 6 minus 32, and those are gone. And all you're left with now is plus 8. And so that's your final answer. Okay? A lot of work. A lot of work, man. And you got to be thorough. You got to be organized to make that happen, okay? Okay, I'm going to erase some of this right here. And just quickly do this last problem for you here. Just another practice here. 5x minus 8y times 5x minus 8y, right? I cannot take a shortcut. I get 5x times what? 5x. This times this. I get 5x times negative 8y, right? This times this. I get plus negative 8y times 5x, and I get plus negative 8y times negative 8y. Okay? Numbers with numbers, 25x squared. Okay? 5 times negative 8 is negative 40, and we write x before y, always. So down here we'll have negative 8 times 5, which will also be negative 40, but not yx, xy, because we put it in alphabetical order. And negative 8 and negative 8 make positive 64, and y times y makes y squared. These two combine, we get 25x squared minus 80xy plus 64y squared. Okay? Solid. All right, that is multiplication of polynomials. Now we're diving into division of polynomials. And in our, these are, we talked about this, these are super, super easy. We take 16x to the 5th, y to the 3rd, minus 12x to the 3rd, y to the 2nd. And what we're dividing by, we then put under each one of these terms, okay, for x squared, y squared. And 16 divided by 4 is 4. X to the 5th over x to the 2nd is x to the 3rd. Y to the 3rd over y to the 2nd is y. And you say, Brother Rich, you went really fast on that. Okay, let's take that one, this one right here, and let's magnify it over here. 16 divided by 4 is 4. X to the 5th over x to the 2nd equals x to the 5 minus 2, which equals x to the 3rd, right? Because this is the quotient rule. And y to the 3rd over y to the 2nd equals y to the 3 minus 2, which equals y to the 1, which is just y. That's how we got that. So coming over here, 12 divided by 4 is 3. X to the third over x to the second will be x to the 3 minus 2, which will just be x to the 1, which is x. Y to the 2 over y to the 2 is gone, and that is your final answer. And you have a problem almost identical to that on this test. It's just a binomial divided by a monomial. In our final one here, we have a trinomial divided by a monomial. And we have 54x to the 6th minus 9x to the 4th plus 2x squared. And we are dividing this by 3x squared. Now, I gotta tell you, I just want to make sure, is this written correctly? Everything good, okay. We're going to divide this by 3x squared. We're going to divide this by 3x squared. We're going to divide this by 3x squared, okay? 54 divided by 3, okay? You put it in the calculator, and you get 18, okay? So you're going to get 18, and you have to check that on a calculator. X to the 6th over x to the 2nd is x to the 6th minus 2, which is x to the 4th, okay? 9 divided by 3 is minus 3. X to the 4th over x to the 2nd is x to the 4 minus 2, which is x to the 2nd. Now these x to the 2nds cancel each other out, and you're just left with plus 2/3. And that is your answer to that problem. Okay, we're going to pause. All right, let's rip and erase as fast as we can. All right, guys, this is a long video, but we're trying to make sure we're there to help you, and you obviously can go through this and pick your poison in different spots. We are now going to cover 47 through 54, the retro problems, the review problems from previous tests. On this board right here, everything is from chapter 3. And chapter 3 was all about lines, graphing, finding the equation, finding slope, finding intercepts, those kind of things. You're given an equation, you're asked to graph this. They tell you can use any method you want. Okay, you can use plug and chug. You can use intercept method. I will be using y equals mx plus b. I am not going to review the other two methods. I am simply going to tell you I'm going to subtract 4x from each side. I'm going to take negative 3y equals, I always put it in mx plus b form. We talked about that, put the x term here. Divide by negative 3, okay, and you get y equals 4/3 x plus 3. We draw a graph, okay. On a multiple choice test, you will have 4 graphs. You've taken a chapter test in chapter 3. You know how this rolls.
Brother Rich, it's not plus 3, it's minus 4.
Thank you.
Or actually, no, it's
Plus
4.
4.
It's plus 4.
4. Thank you. Brother Rich is getting tired. It's late. It's good. Sorry, guys. Thank you for jumping in and saving us. That is, that's awesome. Plus 4. So we're going to go on our y-axis up 1, 2, 3, 4. Okay. In essence, we got to go up 4 and over 3. But notice, wasn't negative 4 over negative 3 the same as 4 over 3? Could we go down 1, 2, 3, 4 and back 1, 2, 3? We can. So, we could, have our graph go like that. If it disturbs you to do that, you can draw a bigger graph, okay? And you can go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. When I say it disturbs you to do the negative thing, you can again come here, that's this, you go up another 1, 2, 3, 4, you go up 4 over 3, you can do this, and ultimately your graph is like that, something like that. There you go. So either way, you could draw them that way. I am going to erase this one because I need this space. These two problems right here are a review from section 3.5. When we need to find the equation of a line, we have 4 steps. Find m, plug m, x, and y into y equals mx plus b. Step number 3, find b or solve for b. Okay, we're going to solve for, I can't write, solve for b. And then we're going to plug m and b into y equals mx plus b. So in this instance here, they already gave us m. Y equals mx plus b. And we know this is x, we know this is y, we know that's m. Then we plug in -4, because we've already found m, our first step. We found it, look, there it is. -4, m equals -3/5. X is 10, that's going to be super nice, because we're going to get some nice cancellation going on there. 5 goes into 10 2 times. This is -4 equals, -3 and 2 makes -6 plus b. We're going to add 6 to each side, and we're going to get 2 equals b. Okay. Just going to erase this problem here, and quickly just show you on this board right here. Okay. Take the equation y equals mx plus b at this point. Y equals m is -3/5, x is part of the equation, and b was 2, right? Y and x stay, we just put in m and b. It's our last step there. It says plug m and b into y equals mx plus b. Now this problem, they don't give you m, you have to find it. And what are the tools for finding slope? Well, when I'm given 2 points, I use the formula m equals y2 minus y1 over x2 minus x1. I take -2 and 3. I take -4 and 6. I call that x and y and x and y and 1 and 1 and 2 and 2. And we talked about this. I always have you label the points, write the formula, and then plug it in so you don't make any mistakes. Remembering that those minuses are part of the formula. Y2 is 6. Minus is part of the formula. Y1 is 3. All over. X2 is -4. Minus. X1 is -2. 6 minus 3 is 2. -4 minus -2.
3.
Sorry, it's 3. Brother Richie's getting real tired. Been teaching math probably 12 hours today almost at this point. I did 6 divided by 3. How about 6 minus 3 is 3? Good thing we got our editors-in-chief here to keep me in the right way. -4 minus makes +2 makes -2. So your slope is -3/2, okay? Now, we have to take y equals mx plus b, and we got definitely -3/2. So what are you going to plug in for y and x? Well, we're going to pick one of these two. We could say this is x and this is y. If that's x, then we have -2 there. If that's y, then we have 3 over here, and we have plus b. These cancel. And the negative and the negative make a positive. So I have 3 equals 3 plus b, right? Well, we subtract 3 from each side. These cancel, and we get 0 equals b. Kind of a fascinating little situation here. Now we take our formula of y equals mx plus b, and we get y equals -3/2 x. And that's the formula because b was 0. Okay, cool. All right, now I want to show you something, okay? We're gonna draw a little barrier here. These three problems are all from chapter 2. And they're all chapter 2 word problems from section 2.6. I want you to think about this for a second. In chapter 2, I'm just going to write this here. In section 2.6, we had 3 kinds of word problems on the chapter 2 test. We had a geometry. We had a consecutive integer. And we had a percent, which was a work backward. And sure as poop, we got those 3 on the board right now. Let's do the first one. The sum of 3 consecutive odd numbers is 159. The key word here is consecutive. The next key word is odd. Okay? So the sum of 3 consecutive odd numbers is 159. Remember, sum means to add. So I have 3 odd numbers, and it says find the integer. So I have integer 1 plus integer 2 plus integer 3 will equal their sum. If I'm adding them all up. And their sum is 159. So what is my first integer? It is x. Why? Because we always start with x. What is the plus comes down part of the formula? What is the second integer? Is it going to be x plus 1 or x plus 2? It's x plus 2. Why? Because these are odd. And you say, well, I thought odd numbers were 1, 3, 5, 7. We talked about this a long time ago. 2, 4, 6, 1, 3, 5. What's the difference between 2 and 4? 2. The difference between 1 and 3, 2. The difference between these first two integers is 2. What's the difference between 2 and 6? 4. The difference between 1 and 5, 4, right? 5 minus 1 is 4, 6 minus 2 is 4. So our third integer is x plus 4. We should have this memorized. I went through it quickly because we've gone through this. This is called a retro problem. It's a review problem. We're not teaching this concept brand new. So integer 2 is x plus 2. Integer 3 is x plus 4. Integer 1 is x. We add all this up. I got x makes 3x. I got 2. I got 4 and makes plus 6 equals 159. I subtract 6 from each side. I get 3x equals 153. I divide by 3. I divide by 3. I get x equals 51. Okay, they asked for the integers. So my first integer is 51. If I add 51 plus 2, that makes 53. If I add 51 plus 4, that makes 55. Look at that. It all worked. Okay, x plus 2 makes my next integer after that. X plus 4 makes my next integer after that, proving that this x plus 2, x plus 4 makes 3 odd integers. Okay, beautiful. Okay, find the length of a rectangular lot with a perimeter of 110 meters. Okay, well, as is the case, is everything working well with this?
Yeah.
We're still going. As is the case, a rectangular lot, perimeter, definitely we got P equals 2L plus 2W. That's been the case throughout the semester. We've been dealing with perimeter of rectangle. And they make a comparison statement where they say the length is 5 meters more than the width. And I've taught you this over and over again to rewrite that. The length is 5 meters more than the width. And we drop down translate. Length is L. Is means equals. 5 meters more, 5 plus than the width, W. So now I can plug 5 plus W in for L. And I can plug 110 in for P because perimeter is 110 meters. So the P is 110. Here's what I have. P equals 2L plus 2W. And where there's an L, I put in 5W. So I have 2 times 5 plus W plus 2W. I get 110 equals 2 times 5 is 10. 2 times W is plus 2W and plus 2W. Okay. None of these problems are inequality word problems. They're not asking you, they're asking you for specific answers, okay? So you're good in this, okay? 2W and 2W make 4W. 110 equals 10 plus 4W. Subtract 10 from each side. We get 100 equals 4W. We divide by 4 and divide by 4. And we're going to get a width of 25. They asked us to find the length. We know that the length is 5 more than the width, so the length is 30. It was meters, so our length equals 30 meters. And we're done with that problem. So you're preparing for this test and you're reviewing, some critical things that we've done in the past. What is the original price of a pair of shoes you paid $85 for at a 25% discount? Round to the nearest cent. Okay, this is a percent problem because of the percent. This is a work backward because they're using the word original. That's a key word there. We know that we paid $85. What we don't know is the cost of the shoes before the discount. So we learned a formula here that we have to have memorized all the time when it comes to work backward. Our work backward formula, okay, is original amount plus or minus a change to that amount will always equal the new total. Remembering that the change is always a percent times the original amount. We don't know the original amount. This is what is the original price. So that is X, that's the unknown. Are we adding or subtracting? Well, it says here this is a discount. So a discount means minus, we're gonna subtract. We're subtracting 25% of the original cost, 25% of X. The new total is $85 because that is what we paid. We paid $85, that was the final new total. Did this person pay 100% of the cost of shoes? No, they paid 75%. If we take these two, we get 75% of x, or 0.75x equals 85, right? These are like terms, 1x minus 0.25x. We've done this many times. Divide by 0.75, divide by 0.75, and x will equal what?
113.33 repeating.
Okay, and so we're just gonna round that to $113.33 was the price of those shoes, okay? We've got two more problems in the retro section. This problem right here, it goes back to a concept that we did in our, can you see, what?
1.8.
Yeah, it is in 1.8. We did this, it was 1.7 actually in chapter 1. This is from section 1.7 where we had a common factor here, right? We have three terms and we're saying basically we have three terms here, and we're asking ourselves, what are they all divisible by? Because factor means divisible by. Well, what do they all share in common? They share a 7. So our common factor equals 7. So we have 7x over 7 plus 21y over 7. Minus 28 over 7. We always put the common factor under each term. We learned this in 1.8, and basically we said we determine what the common factor is. That's step number 1. Step number 2, we place it underneath each term, and then we simplify. That's step 3. This cancels out, and we get x plus 3y minus 4. We put that in parentheses, and the common factor goes outside of it. So we know that this makes this when we multiply it back out. They're actually including this in this test because chapter 5, what we're going to get into, is all about factoring, and so they're just kind of giving you a whetting of the appetite, the math appetite for factoring. Come on over here. This is from chapter 2. Is that up here?
Yeah.
Okay. So we're going to solve this. Equal sign. 3-step process to solving. Okay. Our 3-step process to solve. Remember, step number 1 is to simplify the equation. Can you see me okay here? I gotta cheer up my butt. Okay. And then there's A, we deal with fractions, right? Are there any fractions in this problem? No. And then B, we distribute parentheses. Are there parentheses? Yes. So we take 2x, 8 times x is plus 8x, 8 times negative 7 is negative 56 equals 14 plus 3x. You gotta love the shake on the board there. Then after we distribute parentheses, we combine like terms, right? Are there like terms on this side of the equal sign? Sure there are. There's 2x, there's 8x. That makes 10x minus 56 equals, are there like terms over here? Nope, 14 plus 3x. Now if you said yes, it's not true. There are no like terms that can combine here, and there's no more that can combine here. But we also said that we get all of our variables to one side, or all my x's to one side. No, I like to subtract 3x, keeping it positive. This makes 7x minus 56 equals 14. Step number 2 is the addition principle. Okay, we're going to add 56, and we're going to add 56, and we get 7x equals 70. And then we have the multiplication principle. And we divide by 7 and divide by 7, and x equals 10, and we are done. All right. It's a lot of work. We've gone through every problem, and encourage you, if you need to review any of these, to spend some time. And if you are having a real struggle with any problems, then go to the math lab and ask them to create some extra problems for you to practice. Good luck.